Hello, my name is Amirreza Zarnaghsh and I am a second year PhD student at the University of Kansas. Thanks so much for listening to my presentation. We know that sediment pollution has resulted in many issues in streams of Johnson County, including forcing organisms to change their habitats, increasing harmful bacteria concentrations, and increasing the cost of treating drinking water. Also, we know that most of the sediment is transported during storm events, and therefore it is very important to understand sediment sources and pathways during storms to effectively control sediment transportation to our streams. One efficient tool to gain this information is to study the relationship between sediment concentration and discharge values during a storm event. This relationship is called hysteresis. In this study, we have used publicly available data to study around 850 storms occurred during 2002 to 2040 in 5 different watersheds across Johnson County. And we want to answer to two important questions. First, we want to understand what are the active source zones and transport mechanisms of sediment across Johnson County and how they are affected by urbanization, rainfall, and other parameters. And secondly, we want to quantify the contributions of proximal versus distal sediment sources in total sediment transported to streams. So here you can see the map of our studied watersheds. We have studied 5 different watersheds with different levels of urbanization. The most urban one is Indian Creek, and the least urban one is Kill Creek with just 16.7% of urbanization. On the right side, we can see 3 typical hysteresis patterns. So clockwise hysteresis patterns shows that most of the sediment is coming from proximal sources like channel bed or channel banks. Counterclockwise patterns show that most of the sediment are coming from distal sediment sources such like construction sites or hill slope. And then we have figure 8, which basically shows that the sediment is coming from both origins, proximal and distal sediment sources. Also, we have used principal component analysis, which helps us to reduce the dimensionality of our data set. So it helps us to take a look at a smaller amount of data without losing much information. The results of our hysteresis analysis show that Indian Creek and Mill Creek, the most urban watersheds, have the highest proportion of counterclockwise hysteresis patterns. So for these two watersheds, a huge amount of sediment is coming from distal sources. Whereas for agricultural watersheds, Kill Creek, Cedar Creek, and Blue River, most of the sediment is coming from proximal sediment sources like channel bed or channel banks or sediments which are located very close to the channel. But increasing the significance of distal sediment sources is not the only effect of urbanization on streams. Here we can see the results of our principal component analysis for 2 watersheds with different land uses. Each point is showing a separate variable, and once the points are close together, we can say the corresponding parameters are more correlated to each other. So for example, for Kill Creek, we can see that sediment concentration is highly correlated with a maximum discharge and storm intensity, indicating that whenever we have higher maximum discharge or storm intensity, we will also have higher sediment concentration in our streams. However, for Indian Creek, we can see that new variables are playing important roles like number 5, which is storm event duration. This is showing that basically urbanization is also changing the controls on sediment transportation to our streams. It is adding new controls on sediment transportation. So the two important effects of urbanizations are, first, they add new controls on sediment transportation, and they change the location of sediment sources. Sediment sources tend to become more distal for urban watersheds.